Okay, we're going to talk briefly about the differences between real and ideal gases. So ideal gases are ones for which PV equals nRT works. And you're going to assume that a gas is ideal unless you're told differently or asked when it deviates from ideal behavior. So when a gas is not behaving ideally, we say it's behaving as a real gas. So a real gas is one that deviates from ideal behavior. And when it deviates from ideal behavior, it tends to do so under two conditions. One of those conditions is if the the temperature is too low. And the other time it'll deviate from ideal behavior is at high pressure. So at low temperature or high pressure, we can expect it might deviate. Now, what we mean by low and what we mean by high depends on which gas it is. The reason it deviates at low temperature is at low temperature, the molecules have very little kinetic energy, and so they stick together easily. And if they stick together easily, they're doing so due to their intermolecular forces. An intermolecular force is obviously a force between molecules. And when they stick together due to the strong intermolecular forces, they end up behaving as fewer molecules. So instead of having like 7 bajillion, they've stuck together, so they're behaving like 6 bajillion or 5 bajillion or 4 bajillion, and we end up getting a lower pressure than we should. At high pressure, they also deviate from ideal behavior, but now it's for a different reason. When we start jamming them closer and closer together, the space between the molecules isn't that big anymore. And now the volume of the molecule itself matters. And one of the ways I've seen this asked is when it says that the volume of the molecule matters is that the molecules have finite volume, meaning we can't shrink them into zero. They actually exist. So again, if you're asked when a molecule deviates, you're looking for when the temperature is low and or the pressure is high. And the reason why, at low temperature, they stick together because of strong intermolecular forces. And at high pressure, they are jammed together and the volume of the molecule matters. Or another way of seeing it asked is the volume of the molecule is finite. And that's it.